Hello there, this is Toby, and welcome to the series where we make a programming language together. We're making SmallLang. You can find the project page here, and we're using the parser generator tool called Nearly.js. And last time we completed the parser for variable assignments, function calls, as well as multiple lines. So at this moment, we're able to parse a very simple program such as this. In this episode, we're going to start writing a generator. The generator's job is to take this AST file, which is a detailed description of this program's syntax, translate it into JavaScript, which can actually be executed and produce a result. So let's get started. In order to build a generator, I'm going to create a new script, generate.js, and I'm going to make a sync main function and call it as I normally do. Again, I'm going to use the file system module to make this kind of thing easier for me. I'm going to read in a file name which is passed in from the command line. I have done a similar thing in my parse script here, so I might actually just steal this code from this parse script here. And here I'll say please provide an AST file, because it's an AST file that generates a JavaScript file. To visualize that, first we have a .small file. We're gonna put that through our parse.js, which gives us a .ast file, and now we're gonna take that .ast file and send it through our generate.js process, which that's what we're making now. And that is going to give us a .js file. And then later we're going to send this .js file through the node process, and that will actually give us results. We're at step 2 out of 3 right now. So let's get back to it. If they gave us this file, now we're going to actually read in the AST file. Let's do it like this. So AST JSON will be received, and to receive it we'll say await fs.read file, the file name. That will get us a buffer object. We'll convert it to a JavaScript string, and then after we have the AST JSON, we need to json.parse that to get the actual AST. And then once we have this AST, we're ready to go through the AST and generate a JavaScript file. I'll say that there's a generate function which we're going to make, which takes the AST and spits out some JavaScript code. And once we have this JavaScript code, we're going to write it as a file. We'll come up with an output file name a little bit after, but basically we're gonna spit out this JavaScript code here, and then we'll say we wrote this output file name. Okay, let's come up with this output file name now. I'll just say we'll take the name of the AST file and replace the .ast extension with a .js extension. Then we're done. We're going to need a generate function for this to work, aren't we? And actually, at the moment, the AST is going to be an array, I believe, because we have represented our program as an array of statements. So because of that, I'm actually going to call this the statements. And I'll have this generate actually be called generate.js for statements. It'll take a statements array. For now, for the sake of testing if this script works, I'm just gonna return a simple hello world program, no matter what the AST says. Oh, that's wrong. Okay, let's try this generate.js and send it this ex2.ast file. AST is not defined. Let's fix that. Line 12, I changed it to be called statements, so that's why it's not defined. FD argument must be of type number. Oh, fs.write is a more low-level function which takes a file descriptor argument as the first argument. I actually meant to use write file, which is a more high-level function that takes a file name. So that was the problem. Okay, so it generated the JavaScript file, which does print hello world. We can even run it using Node.js. And there it is. It works. And we have a working well, it doesn't work because it doesn't actually translate the AST. So now let's make it translate the AST. Let's start small. Let's go back to the first example where we simply had one assignment statement and try to translate that one. Actually, we need to reparse that one because we have changed things since then. The top level is supposed to be an array at this point. So reparse example1.small. And now example1's AST file has an array wrapped around the statement, then which is what it should be. So let's loop through the statements. I used the for of syntax to do it. And I'm gonna make an array to receive the results of translating each of these statements actually. So say I'll make a variable called lines, and then at the end I'll just join the lines together like this. But inside of this for loop, I'll make a generate.js for statements. I'll generate a line of JavaScript via another function call, which I'm going to call generate.js for statement singular. And I'm gonna define it here. So a statement, if we look at our grammar, a statement can either be a var assign or a fun call. And then later on, we'll encounter things like expression and stuff like that. And actually, I'm thinking to make it a little bit more convenient, I might just sort of merge statements together with expressions, because expressions, oh, it's not the case, but really we should allow function calls to be expressions as well, which we're gonna have to test very soon. So like function calls really belong here. I'll do that a little bit later, but for now, I'm thinking just have one generate function for both statements or expressions, for statement or exp. And then here, because we're looping through this array, at the moment we only have to handle the var assign type. We'll just say if statement type is var assign, then we're gonna generate the appropriate JavaScript statement for that, which is going to look like something like let's go var, because I don't really want to deal with scoping issues for now. And var in JavaScript is more lax about scoping rules. We're gonna have the variable name equals JSExpr, and then a semicolon. Okay, so now we have to get the variable name. Variable name can be gotten from that guy or the statement. I'll call this exp then, or maybe just node, standing for AST node. So I got this node, and I'll say the var name we're gonna get via node.varname.value. So that will give us the variable name, and that goes in here. And then as for the JavaScript expression, which is on this side, is a string literal in this case, but it could be a bunch of other things. I guess for now, it's going to work if we just grab its value. We can do the same thing here. And for now, that's going to work, but later on it's not. Okay, so we'll take this line of JavaScript, return it. It's gonna get returned back here, and then, oh, I forgot. We're gonna push it into the lines array. And then this will have it, and the end we'll join it all back together. So now let's try this. I'm gonna say node generate example1 AST. Generate JS for statement is not defined because I renamed it. Okay, now it worked. Generates the example JS, and that looks good. That looks like a valid line of JavaScript. So if we have more of these, then we redo this process. First, reparse the example file, and then we regenerate the JavaScript file, all of this works. Okay, great. There's one thing though. I want to address the issue that I found earlier, which is that we should be able to call a function, say sum equals add 1 and 1. We should be able to call a function, and the function should be a valid expression as well. And at the moment, the grammar does not support that. I'm going to reparse it, and it's going to fail. It's going to say, oh, that confused me. I wasn't really expecting to see an open paren because I expected the right-hand side to be an expr. And what's an expr is either a string, a number, or just an identifier. So I was okay up until this point. Like if you did this, I would have been happy, but this is not happy. So to fix that, we're gonna say, well, an expr can also be a function call. After changing the grammar file, we have to regenerate the parser. Okay, now let's try to reparse this, and now it's happy. It allows for the value part of the var assign to be a function call like this, and now it's perfectly happy. Great. Now we're gonna do something a little bit more tricky, because we could potentially have a more complex expression, like we're stringing together a bunch of operations. A complex expression like this with a bunch of nested function calls. So you can see a bunch of nested function calls here. There's no limit to how much you can nest. You can keep nesting a million times if you want. And we want our generator to be able to handle that. How do we handle that? We're gonna need to handle it with recursion, whereas this is an AST that says it's an add between one and another function call. So this is the AST here that I have depicted in the form of a tree. So basically what we want to be able to say is have a generate function, which we're calling generate.js for statement or expr, but in this diagram, I'm gonna shorten it to gen. We're basically saying I wanna be able to gen this whole AST tree and have it spit out some JS, right? But in order to do it, we're gonna do it recursively, as in the gen of this whole tree is gonna call the gen of this subtree, and then the gen of this subtree is gonna call the gen of this smaller subtree, and then actually we'll recursively call it on the numbers as well. We're gonna gen this number, we're gonna gen this number, we're gonna call gen on this number, we're gonna call gen on this number as well. At the leaves, when the gens for the leaves return their value, the values get returned to here and then sort of combined, mixed together into this pot, and then get returned back. And then when these things get returned back, they get mixed together and then return back, and then this guy returns back, they get mixed together, and then finally return back. So that's how this recursive scheme is going to work. Let's see it in the code. Okay, so we're gonna say I actually can't assume that the node has an immediate value anymore, because if you look at the AST here we're doing node.value, and that worked out fine for a string literal like this. And it even works fine for a number like this. However, it's definitely not going to work for a fun call, because a fun call doesn't have a dot value. A fun call has a fun name and arguments, but it doesn't have a dot value. And if we run this, it's going to break. Let's run it. No, it didn't break. That was actually unexpected. I want to see what it did. Oh, just undefined. Oh, because value would be the fun call object, and then that value on this object, it doesn't have that value, so we got undefined. What we want to do is recursively call this function given this object as the node. So this object is the value, so node.that value, but then we're gonna basically use the exact same function to go through this guy and convert it to JavaScript. However, in order to do that properly, we're going to need another if statement that knows how to handle fun calls. I'll say else if node.type equals a fun call. Then do the thing that's required for fun calls. But however, this is gonna break for string types and number types now. So we actually need more conditional statements. One for each type of AST node that's gonna come through. And there may be more in the future, but for now, so that this gives me a notification when I try to generate some AST node that I haven't written code to handle, I'm gonna throw an error here. So now let's go back and fill in the blanks. The string and number are particularly easy because that would just be the value field of this object, what we should return. Now let's handle the fun call case. Let's grab the function name, which is going to be node.funname.value. And then we're going to have a bunch of arguments. Each argument is actually another expression, and we'll need to convert each individual argument into JavaScript as well. But luckily, we already have a convenience function that does it for us. It's generate.js for statement or expert. So I'm going to loop through each argument in the arguments array and call this function for each one. The shorthand for doing that is using array.map. Note.arguments.map. I'll do a little arrow function here. And then we'll return the result of calling this function with the arg. At the end, we're gonna get an array of the JavaScript strings, and we'll just join them together with a comma. So the result of this whole thing should be an argument list in JavaScript. So finally, we're going to format a JavaScript function call, which just looks like the function name, open parenthesis, and then the argument list, and then a close parenthesis. Okay, let's try this. And that looks good. It's able to recursively go through any number of levels of nesting all the way to the last level, which was here, and then generate the JavaScript for each one. So that looks great, and I'm gonna stop here for this episode. In the next one, what we're gonna do is try to make this programming language somewhat useful by adding some useful runtime functions. So I'll see you next time.